Right. Now let us come back and learn the next set of reactions for the same amine. Primary amine only. I am comparing different sets, common types I am trying to give you. Same story again. Alkyl halide, silver nitrate treated. You will get the nitroethane. From that, nitro are converted to amines always. So I will get this. Now what happens if I take this amine and I am going to perform a reaction called aminolysis. Okay, very important reaction in this chapter. Aminolysis. Right. So what actually is this? See, lysis means cleavage. Which one is cleaving? Amino group is cleaving. So what actually is aminolysis means? Suppose if I take an example, first I'll take a general example, then I'll go to the specific examples. Now in general examples, if I'm taking a primary amine RNH2 and I'm adding right to this particular thing, let us assume I'm taking an amine. I'm not taking the actual ammonia until now. Let's see. To this I'm going to take an alkyl halide, add an alkyl halide. So first what is going to form, just see. Okay, let us write X this side, R this side. Just general thing. Hydrogen, one hydrogen here. First important thing, HX comes out, minus HX. This whole group comes and adds to this R, nitrogen, hydrogen, one more R group. Done. Now to this I'm going to add one more RX. I'm still not going into the aminolysis reaction, just see. One more HX comes out and you get R, N, R, R. Still one more RX combines. Yes. Now where is this H to remove? Just see what's going to happen. It's going to add to this nitrogen, like it's going to form a compound called R3. No, it is R4, isn't it? Sorry, it is R4. NX, quaternary ammonium salt. This is the main concept. It's going to form quaternary ammonium salt also. Now let us start seeing the examples. Now suppose I am going to take two important examples. First one, the first example is, just take ethylamine, the same thing. C2. Okay, not ethylamine. First, I am going to take ammonia. For aminolysis, the concept is the same. But here, I am going to add ammonia. The addition of ammonia to alkyl halide is called aminolysis. Okay, what is aminolysis? Aminolysis is the process of addition of ammonia to an alkyl halide. It can be ethyl, propyl, anything but halide, alkyl halide. So when you are adding, the first important thing, what is going to happen? There are three hydrogens. In these three hydrogens, okay, I am writing like this. One H and Cl comes out. What do I get? I get a C2H5N, H and H. Done. So what is this? Ethyl or ethanamine. Ethylamine. Now to this thing, again I am going to add one more. Now amine is already entered. Now I am going to add C2H5Cl. One more. Same, see here. I am adding this one, RX, that, now C2H5Cl. Now again one HCl and this one comes out. So every time you are trying to add to this, what do I get? I get C2H5 and C2H5 and H. Diethyl ethanamine. Now to this particular thing, you are going to introduce one more C2H5Cl. HCl comes out and you get N, C2H5, C2H5 and C2H5. Triethylamine or ethanamine, triethyl. 1, 2, 3. Triethylamine. Right? So this is your aminolysis. Now let us take one more. Here, what did I take? I took alkyl halide. Now if I am going to take aryl halide, RCH6. Same story, aminolysis. You are going to add, take out hydrogen, take that hydrogen out, first hydrogen out. Every time ammonia is adding to alkyl halide, that is your aminolysis. Okay, now C6H5, N, your hydrogen is one side, HCl has come out. Yes, done. NH3, no? 2. Now again to this you are going to add one more aryl halide. This hydrogen HCl comes out and you are going to get a secondary compound with 2 aryl groups and 1 hydrogen. Now further you are going to take this aryl halide, introduce one more to this, because every time you are trying to replace, isn't it? Finally I get this compound. Further, see here, now this is with your triethyl aminolysis. I've taken ammonia to primary. Here I've got aryl compound 3. Further, if you take, now I am at this stage, this is the stage here, this is the stage here. Suppose further if I take and add, I get this salt, I get this salt. Simple. So this is the aminolysis process. Once again, what is aminolysis? Aminolysis is a process of addition of ammonia to an alkyl halide. Right? Every time what is happening? One hydrogen gets replaced. It goes on, it gets replaced till all the hydrogens are done. Yes, so let us come back and start with your preparations of primary amine. That is your chapter main content. Now whenever you're learning this chapter, remember what am I going to do? I'm going to teach you the conversion also. I'm going to teach you the preparation also. I'm going to teach you the chemical properties also, so that everything is in the same page. So whenever you're watching this video, because I upload it on daily basis, if I write amines, so take one page, okay, take one register, both the sides of the page, note the whole reactions, all the reactions which are linked to amines. Okay, what is the use in the exam when you are trying to learn? Everything will be under those 2 pages or 1 page based on your handwriting. So that is how I'm going to teach you. Even the conversions will be there. So now when I have to learn primary amine, first important thing, you are going to take an alkyl halide. To this alkyl halide, you are going to add silver nitrate, which is alcoholic medium. Why do I add? Because this will precipitate out. When this is precipitating out, you get CH3, CH2NO2, nitroethane plus silver bromide. Done. Now I said always nitro is converted to amino, after amino only cyano. So this nitro is going to get converted to amine. How? I have to take out this oxygen, I have to add one hydrogen to this, which will get me the hydrogen. Reducing agents will get me the hydrogen, isn't it? So your reducing agents can be both. Just see, it can be SN plus HCl, metal acid, or it can be lithium aluminium hydride, both reducing agents. So what will these do here? Important, try to add 6 hydrogens. I am writing 6 hydrogens directly. Why ma'am? Why are you directly writing 6 hydrogens? Because just see, for this how many I need? 2 hydrogens. Let us write that. So both will give the same product. In the paper, if you see these 2 agents like this, okay, blindly remember the examiner wants you to add hydrogen to that. So reducing agents. So now CH3, CH2, NH2. How many have gone? 2 have gone. Still I have 4. So 4 will come out as 2 water molecules with this oxygen. Oxygen is 2, 2. Hydrogen is 4, 4. Plus 2, 6. Done. Now I prepared primary amine. This is your preparation. Now this primary amine, why? Just see, when I am going to introduce 3 important compounds. One is, this reaction is called acylation reaction. This reaction is called benzoyl ation reaction. This reaction you are going to add, or we call it as Hinsberg test also. Okay, you can see that. Hinsberg reagent. Hinsberg's reagent. Now, what actually is this acylation? Acylation is addition of CH3COCl, acyl group. Benzoyl ation is addition of C6H5COCl. That is your benzoyl group. Benzoyl. Hinsberg reagent is C6H5SO2Cl. This is Hinsberg reagent. Okay, let's see. Now what will happen in the paper? If they give you primary amine, you have to add this and see, just addition only. Now let me write the reaction down. I am taking this and this first. Your CH3, CH2N, one hydrogen here, one hydrogen here. I am going to add acylation reaction. Cl, try to write it on this side. C double bond O and CH3. As soon as you add acyl group, HCl is eliminated. Now when HCl is eliminated, this group goes and joins to this group. So I'll write this as C2H5. Not problem, right? So now NH. This is C double bond O. This is CH3. Now what is this compound? This is called amide. Let us write the product and name the compound. So I'm writing that product here. C2H5NH CO Now how many do we have? Here you have ethyl group. Here also you have ethyl group. How to name? Both are in the terminal corners, means terminus. N comma N. Diethyl. 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 Yes, what amide is it? Ethane. E-A-T-H-A-N-E is ethane. No, take out that E and add amide. Ethanamide. That's it. Simple. This is called acylation. Now let us do benzoylation to this reaction. Same procedure. So in benzoylation, what is the difference? Here you have your benzene ring, isn't it? C6H5. Okay, your benzene ring. Same procedure. Minus HCl. Join these two. C2H5. NH. C double bond O. C6H5. Amide linkage. Yes, now let us write the product here. C2H5 NH C double bond O C6H5. Right? So now what is this compound? Now N. This is phenyl. Phenyl ring, isn't it? Not benzyl. Phenyl. One hydrogen less. So phenyl. Right? Now ethanamide. Ethanamide. Why amide? Because this group. Now let us write Hinsberg reagent. So in Hinsberg test, what should I take? I am going to pick up CH3, CH2, NHHH. I mean, take this Hinsberg reagent. How are you taking? You're going to take chlorine in this side. S double bond O, and your benzene ring. Eliminate HCl and form the product. What product do you get? C2H5 NH S. Simple. Let us write that product. Yes. Now, what is this compound? This compound is benzene. This compound is sulfonamide because sulfonamide. Okay. Now, this is ethyl, right? Now, you can write ethyl, benzene, sulfonamide. Benzene, sulfonamide. Sulfonamide. Simple, isn't it? Now these are the complete reactions. Okay, this is one set of reactions which you can study directly. So now let us come back and start with the next set. The same thing again. I'm using the same ethylamine and we are seeing further 3 more reactions. So now same story. You're taking alkyl halide, you're adding silver nitrate, you're getting nitrobenzene. One reduction is giving ethylamine. Now to this ethylamine, if in the exam if they give you such reactions, right? Now simple. This is your chloroform, and there's a difference between, please see, there's a difference between CHCl3 and CH3Cl. Lot of difference. This is chloroform, this is methyl chloride. Now what is this compound? Chloroform. CHCl3 is chloroform. Now in chloroform, if you are in the presence of a base, potassium hydroxide, strong base. Now this, if you are treating amines with chloroform and potassium hydroxide, that particular reaction is called carbylamine reaction. Remember that. Or it can also be called as Hoffman's isocyanide test or isocyanide reaction. Okay, let's see again. Whenever you see chloroform combination with KOH, yes, that's also called, this reaction also is called carbylamine test or reaction. How do I write in words? In carbylamine reaction, okay, when a primary amine, okay, let us write that also. How should I write? Carbylamine reaction or test. Now, what is happening? When primary amine is treated with chloroform. What is chloroform formula? CHCl3 and a base. Here we are going to take KOH. Yes, so 3 moles I have taken. KOH. Yes, it forms an offensive smelling compound. That is isocyanide. That reaction is called carbylamine. Okay, I'll also explain you the carbylamine reaction. As of now, simple, remember. This, when it is treated with chloroform KOH, nothing to do. Write the whole thing like this. Okay, let me write it as R for you better. NH2 will turn into a compound called NC, which is a bidentate, both the sides. It can form C and NC because it is a bidentate like that. It's getting attacked to a highly electronegative nitrogen atom. So this is called isocyanide compound or carbylamine reaction. Along with that, you have 3 potassium, isn't it? Now 3 will come out as 3 KCl. And water molecules will come out as 3 water molecules. Once again, amine, when you see with chloroform and KOH, convert amines to isocyano compounds. This is called carbylamine test. Amine to NC. Amine to NC. So once again, somewhere you'll remember NH2 to NC is carbylamine test. Along with the KCl in water. Done. Now what should we do? Now I'm going to take the same amine, and in the paper if it is given as HCl, okay, what to do? Don't get confused, nothing to do. With HCl they're going to form salts. What salt? Just see. Now just take this HCl, add to this. CH3, CH2, N. Now NH2 plus H becomes NH3Cl plus N minus. What is this compound? You have 2 carbons, isn't it? So N-ethyl ammonium chloride. Again, N-ethyl, I don't have place to write, I'm just explaining N-ethyl ammonium chloride. Now, suppose, instead of primary amine, if I have, okay, instead of this compound, now I have carbylamine done. Primary amine, this is my ammonium chloride salt done. Instead of primary, if I have a secondary amine, let us see. Now C2H5, C2H5 and NH. I'm going to add HCl, okay, to this. Same story, isn't it? Now this becomes C2H5 taken twice, NH2Cl. Done. Now what happens if you don't have any hydrogen group for tertiary? See what's going to happen. This whole thing, I'll write it as 3 times. It's going to form then 2. It's going to add to this H and form Cl. NHCl minus. So tertiary ethyl ammonium chloride. Same. This is primary, that is ethyl ammonium chloride, secondary ammonium chloride, tertiary ethyl. Here secondary ethyl. So tertiary ethyl ammonium chloride. So it's going to form an addition compound converting into salts with HCl. Okay. So amine, basic, acid combination forming a salt. So remember these reactions. This is a second set of reactions. So we've already learned how to prepare amines, right? What did we learn? We've learned reduction of nitro compounds, reduction of cyano compounds, and reduction of amides also. Then gradually we went into a topic called Hoffman's bromide reaction. What did I say? By Hoffman's I can prepare the primary amine, both aliphatic and aromatic. So let us come back to one more name reaction, that is Gabriel Phthalimide reaction. So important. So what actually is this reaction? This particular reaction is going to use a compound called phthalimide. That is why it is called Gabriel Phthalimide. Don't get confused in the exam. Phthalimide is a very simple compound, just how to write. So first try, as soon as you see this word, draw the structure of phthalimide. Your benzene ring. Okay. So aromatic, done. And you have CO. Okay, done. Basically, if I say amide, it is CO and H2. Now, imide means both the CO groups, you have only one NH linked. That's why this is called imide. One nitrogen, so imide. So this compound is called phthalimide. So phthalimide, what are you going to use? You're going to use the most important thing, alcoholic KOH. This is very important. What is this? What is KOH doing here? KOH is going to supply this OH minus. That's why we call it as nucleophilic substitution reaction here. This KOH in the presence of an alcohol is going to supply that OH which will replace. Now, actually, if I have to see the, when I go to the background part of this, now your phthalimide, you can remember this before you go to the exam, first gets converted to potassium phthalimide. This potassium phthalimide gets converted to N-alkyl phthalimide. This N-alkyl phthalimide further gets converted to phthalic acid. And we are getting our primary amine out. Okay, right. Simple. This, if you remember, this phthalic, this whole step, everything is easy. So phthalimide, remember, because if you see the name reaction, simple. Now let us go with the step. Now this KOH, I said, is going to supply OH in the nucleophile. Now first important thing, there's a cleavage of the bond here. This potassium, okay, there is a cleavage of the bond here also. This potassium goes, because I said this is going to supply, this comes out as water, and potassium goes and attacks this nitrogen. What product do I get? I get one benzene ring, CO here, again CO, join this with NK. Now what is this compound? Potassium phthalimide. Okay, let us write, I have written phthalimide here. So this is potassium phthalimide, because NH, phthalimide, done. Now to this potassium phthalimide, you are going to introduce an alkyl group. Why am I introducing alkyl group? Because alkyl halide. Why? Because this alkyl halide will come out as amine here. Yes, simple. Let's see this. So alkyl, this RX, done. Now what's going to happen here? This K comes out with X and alkyl groups goes and occupies this position. Let us come down to this. CO, what did I say? N-alkyl phthalimide. See here. N-alkyl, okay? N-alkyl phthalimide. Done. Now still we have not completed. From phthalimide, suppose let us write N-alkyl phthalimide. Don't write A by mistake, it will go wrong. Now this N-alkyl phthalimide, further if you hydrolyze this, done. When you hydrolyze this reaction, what do you get? If I'm taking 2 moles of this like this, there is a cleavage of the bond here. There is a cleavage of the bond here and here. Your R, N, these two which are formed from alkyl group will come out with these 2 hydrogens forming RNH2. Have we not prepared primary amine? Yes, we have prepared primary amine. Now what else is left? Your OH and OH goes and adds because the bond broke here and here. Done. That has come out. So this becomes minus and minus, isn't it? So this one goes and joins to this CO group, and what do you get? You get a compound called phthalic acid. See here, COOH and COH. This goes and attacks here. This goes and attacks here. This is called phthalic acid. P is silent, phthalic acid. So just see. Let us compare. Phthalimide, first compound, yes. Alcoholic KOH, yes. Potassium phthalimide, done. N-alkyl phthalimide, done. Further hydrolysis, phthalic acid and primary amine. Primary amide, no. This is primary amine prepared. So how should I write this name? Statement, word statement. Gabriel Phthalimide synthesis is a synthesis which is a reaction which is used to synthesize primary amines. When phthalimides are treated with alcoholic KOH, which is going to supply OH minus ion, hence nucleophilic substitution reaction, and further it's going to form potassium phthalimide, which further in the presence of an alkyl group. Okay, so let us write KX here. In the presence of an alkyl halide, you're going to get N-alkyl phthalimide, with on further hydrolysis forms phthalic acid and the required primary amine is prepared. So this is how you're going to write the word statement in the exam. If you don't remember, at least try to learn this and go. Reaction if it is confusing, try to learn this. You'll be given at least 30% of the mark. Almost most of the reaction, 90% of the chapter is done. If I have to say specifically, 95% of the chapter is done. We are left with last part of the chapter. Then I'll be doing so many reasoning questions. Then I'll come back to your board papers. Now when I have to see the reactions due to benzene ring, now simple. Your amine or aromatic amines, that your aniline. Aniline basically shows 2 types of reactions. One is involving benzene, that is that first type of reaction is reactions involving benzene ring, and in that reactions involving benzene ring, the first type of reaction I am going to teach you is halogenation reaction. After that, you'll also be learning about nitration reaction, and you're also going to learn about sulfonation reaction. Done. When I have to learn the second category of reactions, it is going to show us coupling reaction, which I've already taught. Yes, simple, with aniline coupled. Okay, let us see that also. So coupling reaction also done. So now this is your basic thing. First we will learn all these 3 and then come back to your coupling reaction. So let us come back and start with your first reactions involving benzene ring, that is your halogenation. So here we are going to add bromine, that is your bromination. So what happens whenever you are taking, let us write bromination now. That is your addition of bromine. Done. So whenever you are taking aniline, simple. Aniline reacts with your bromine without any catalyst. Directly you're going to add bromine to aniline. It forms 2,4,6 tribromo product. So nothing, no catalyst required. I'm going to add this. Directly, how many I'm going to add? 3. That means total of 6. Now observe carefully. As I said, due to resonance, ortho, para and ortho positions are opened up. Now this is a site where bromine goes and acts. So I said it immediately reacts with bromine. So you get aniline with ortho para and ortho positions all are occupied because those are the sites of where we have shown resonance. So this compound is called 2,4,6. See, this is 1, 2, 3, 4, 5, 6. So 2,4,6 tribromoaniline. Done. What else is left? 3 are over. I still have 3. So the hydrogens which are there present at this particular sites here, here and here, those will come out as 3HBr. Now observe carefully. 3 plus 3, 6 bromines are out and 3 hydrogens which are there in the ring are this. So this is your compound. Now at a stretch you've got 2, 4, 6. Now suppose if you want mono substituted halogenated compound, what should you do? See that. Now this is for all together. Now second, to obtain mono substituted anilines, this is the procedure. Please observe carefully. First, what are we going to do? You are going to take aniline. To this aniline, you are going to add or you are going to allow it to undergo acetylation process. Acetylation. When you are allowing it to undergo acetylation, this will form a product called acetanilide. Acetanilide. This acetanilide, further you are going to allow it to undergo halogenation, that is your bromine in the presence of acetic acid. When you are allowing it to undergo this process, halogenation process, okay, I have to write halogenation here. Acetylation is addition of CH3COCl, acetyl group. Then when you are trying to halogenate it, acetanilide will get converted into 2 products. One is orthobromoacetanilide and parabromoacetanilide. This on further hydrolysis, when you're further hydrolyzing it, the acetic acid comes out and you get orthobromoaniline and parabromoaniline. Okay, this is your thing. So let us write orthobromoaniline. This is your compound. Let's write the reaction now. So first important thing, let us take aniline. I'm going to say I introduce acetylation. Acetylation processes addition of CH3COCl. Try to write it in this way. So this H and this Cl comes out as minus HCl. What are we left with? Only NH, isn't it? NHCOCH3. Your ring with NHCOCH3. This is called acetanilide. Now this acetanilide, now we are going to halogenate it. This is here. You are going to allow it to undergo halogenation. So halogenation, which halogen are you getting? You are trying to get bromine with acetic acid. So this bromine goes and adds to that. You get 2 products, I said. One is NHCOCH3, that is orthobromoacetanilide, plus you get one more product, that is parabromoacetanilide. Orthobromoacetanilide, parabromoacetanilide. I have written here. This is the minor product. Ortho always, para is major. Now further, what do? They are going to hydrolyze this H plus water. When you're hydrolyzing it, observe carefully. This comes out as acetic acid, CH3COOH. Now left over, your ammonia is NH is here, NH is here. That picks up hydrogen from here and becomes NH2 and NH2. So what do I get? I get aniline. This is orthobromoaniline 1. Second one is aniline with parabromoaniline. So let's see whether I've written correctly or not. This is your actual base reaction which you have to remember and go. This is your base reaction. Just see. First aniline. Acetylation. Hope this is CO. Hope it is clear. Yes. Acetylation. What is removed out? HCl. So I get acetanilide. To this acetanilide, I am going to halogenate it. Halogenation, bromine in the presence of acetic acid. Then you get a mixture of two products. One is orthobromoacetanilide and parabromoacetanilide. After that, you are hydrolyzing it. Then acetic acid is out. Not just balanced. I've written acetic acid out. And aniline with orthobromoaniline, separate product. Parabromoaniline. This is major. This is minor. So this is your halogenation reaction of aniline. Now remember, now we have done this, isn't it? Suppose in the exam, instead of this, right, if something else is given, what else is given? Let us erase this. The same Hinsberg reaction, I write it in different. Here, what did we take? We have taken a primary amine. Now suppose if I take an amine, that is a secondary amine. Okay, now that secondary amine, let me take C2H5. Okay, I'm just taking C2H5. You can write like this also if it is confusing. C2H5, not a problem. To this, I'm going to add Hinsberg reagent, that is Cl, S double bond O, and your benzene ring. Same story again. Take out HCl and join C2H5N, C2H5, SO2 and benzene ring. This is one more modification of this. Instead of primary amine, I took secondary amine, nothing else. Now tertiary amine can I take? I can't, because there is no replaceable hydrogen atoms. So this, how do you name this? You have two terminals, you have two ethyl groups, N, N. Diethyl, sulfonamide. Which sulfonamide? Benzene sulfonamide. Benzene sulfonamide. Okay, I don't have place here. So benzene sulfonamide. Okay, now remember preparations. 1, 2, 3, 4. All 4 at one page. Please write it like this only. It is easy for you to study in the exam. So let us come back and do the next reaction, that is your Hoffman's bromide reaction. Basically, when in the exam, suppose this is given to you, you don't remember anything. One line at least, please try to learn and go. I'm talking about students who, like, if you tend to forget. One important thing. What? Hoffman's bromide synthesis, this is used to prepare just one line. Remember this line, at least you will get 1 mark. Used to prepare aliphatic and aromatic, yes, primary amines from, right? So from where, if you can at least remember till here, okay, from where, that is important, that is also important rather, from amides. Yes, so at least this word, please remember and okay. Now let us go into the basic thing. Now whenever you're preparing or whenever you have to prepare any primary amines or primary amines, that is aliphatic primary amine and aromatic primary amine. Simple. We try to use Hoffman's bromide reaction. What is that? As the name suggests, bromide. Simple. Now what are you going to do? First take an acetamide. Take one acetamide. To this acetamide, you're going to introduce bromine gas, G. This bromine gas, we are going to introduce, or this is going to we are going to carry this reaction in the presence of a base, strong base. Then when you're carrying this whole thing under these conditions, simple, you just start from here. You're going to pick up 4 moles of KOH so that it's easy. Now, then you get a product called alkyl amine plus your KBr plus K2CO3 plus water. So when you balance this, this also 2, this also 2. So this is the basic reaction, right? In the exam, you have to show this reaction with examples. Now I said we are going to prepare both aliphatic and aromatic amine. Let us take first general example. First, acetamide. What is acetamide? Now this is your acetic acid, isn't it? This is your acetic acid. Now what am I going to do? I am going to take out this OH and I am going to add NH2. Now this becomes acetamide, amide group, acetamide. To this acetamide, I am going to add bromine gas. Along with that, we are going to add a strong base. How many did I take? 4 moles. Now observe. First important thing, this particular CO, isn't it? Is there, isn't it? Now this CO, observe carefully. This whole CO will come out with this potassium as carbonate. Remember, why? In acetamide or Hoffman's bromide, you get an alkyl amine with 1 carbon less. That is the main concept. Okay, acetamide to alkyl amine with 1 carbon less. This is very important. Don't blindly write carbon less. Don't blindly write when you see amide. Don't reduce it and please don't do it. 1 carbon less amine should be prepared. So now how many carbons you have? 2. Now take out 1. This will become CH3NH2. This is 1 carbon less, isn't it? This is 2 carbons here. 2 carbons here. This is 1 carbon here. What is this compound? This is primary amine, that is methylamine. Now, okay, methylamine. Now done. Now let us see. This part is over. Let us come back. Now you have 4 potassiums, right? 1, 2, 3, 4. Okay, now OH is like this. Simple. Reaction is very simple. How should I write? First important thing, your potassium with bromine comes out as KBr. Okay, now how many did I take? 4, isn't it? Now in this KBr, let us pick up these 2 or out. So 2 KBr. Done. Still I have 2 potassiums. Yes. Now you also have CO. Done. Like K2. CO. So this is out. This is out. Done. These 2 are out with Br. Done. These 2 are out here, K2. Now CO is also coming out, but observe carefully. CO3. Potassium carbonate. Now here potassium carbonate, now observe 3 oxygens have gone. So 1 gone, 2 gone, and this also has gone. Now what are we left with? I am left with your hydrogen 1, 2, 3, 4. So 2 2s are 4. So 4 H2, okay, 2 2s are 4. How many oxygens? 2 oxygens, water. So 2 hydrogens, 1 oxygen, 2 oxygens. So 2 2s are 4 hydrogens, 1, 2, 3, 4, and 2 oxygens. So 2 oxygens. Simple, isn't it? So I have got, this is your Hoffman's bromide reaction. Now suppose if I have to prepare, this is your aliphatic amine, isn't it? Yeah. Now let us prepare aromatic amine. So for that, what am I going to do? I am going to take benzamide. This is CONH2. This is benzamide. To this benzamide, I am going to add bromine gas again. You add 4 KOH. Same thing. Here you are going to get 1 carbon less. Careful. So you are going to prepare benzene ring. This CO comes out as potassium carbonate, as I explained earlier. Products are the same. 2 KBr. I've explained earlier, isn't it? 2H2O. And the leftover, this is gone. I'm going to get aliphatic amine. So this is aliphatic amine or aniline. Aniline. Simple. So most important thing is picking up bromine gas, because bromamide reaction, and important thing, you are taking 4 KOH, 4 moles of KOH. Otherwise, you will end up writing some product which has the same number of carbon atoms. Wrong. The product will have with 1 carbon less. Here CO, benzene ring, here no CO. Here CO and H2, here no CO. So this is your Hoffman bromide reaction. So let us come back and do the nitration property of your aniline. So till now we've studied the halogenation, that is your bromination of aniline. Let us start with nitration. So whenever in the exam, if you're asked to do the nitration procedure, for nitration of aniline, you require a nitrating agent. That is understood, isn't it? So the nitrating mixture which we are going to use is nitrating mixture, which we are going to use concentrated HNO3 plus concentrated H2SO4. We already know the electrophile which this is going to supply. You have studied in grade 11 even the small mechanism where you're shifting the NO2 plus group, right? So NO2 plus cation, I'm sorry. So the electrophile which is going to supply is NO2 plus. Done. Now first important thing, aniline does not undergo nitration directly. First reason is aniline, when you're trying to allow it, or if you're allowing it to undergo nitration, it will just directly gets oxidized. Most important thing, yes, you have to note it somewhere. Aniline gets oxidized on direct nitration. That's why what do we do? First we are going to introduce or allow it to undergo acetylation process. So this is again the same like earlier one. First you acetyl, why are we allowing it to undergo acetylation? Then with acetylation we'll lock this compound, this particular thing. Yeah, and amine I'm going to lock. Then I can easily nitrate it. So acetylation can be performed by using CH3COCl or even acetic anhydride also. So here what am I going to do? See, either CH3COCl or here I'm going to use acetic anhydride. This is acetic anhydride. So what happens? This acetic anhydride, this will go and break up this bond. And what do you get? You get first, this will lock amine. It will form NHCOCH3. Watch the earlier video. I've shown you how HCl has gone out. And so now what is this compound? This is called acetanilide. So this acetanilide, now I'm going to introduce this nitrating mixture, right? So that will supply your NO2. So you are going to add concentrated HNO3 and concentrated sulfuric acid. When you are adding these two, the electrophile NO2 will go and just occupy the ortho position, para and ortho. You will get both the products. Because of resonance, we have already seen this is already locked NHCO CH3. You get one at ortho position. This is ortho nitro acetanilide plus para nitro acetanilide. These two are the products. Acetanilide. Done. So still our nitroaniline is not formed. So this further, now which is my minor in this? This is minor product. This is major product. Then we are going to further hydrolyze it. Yes. When you have further hydrolyzing it, we very well know this particular acetic acid comes out. Here also you have CH3COOH. If I take 2 moles, suppose if I take, let us assume I'm taking 2 moles. 1 OH here, 1 OH here, 1 hydrogen here, 1 hydrogen here. So what do I get? Again I get 2 products. One is here aniline, that is orthonitroaniline, O-nitroaniline, which is a minor product. After that, I am also going to get para-nitroaniline, which is a major product. This is your major product. That's it. So this is how you're going to do nitration. Never in the exam, please don't directly take your HNO3 and do the nitrating procedure. Wrong. You lose mark for that. First try to form acetanilide, then only convert into orthopara. After orthopara, further hydrolysis. So what is the reason? Aniline undergoes, I'm writing the same reason here, aniline. Okay, aniline. What in aniline? What is this? Your whole thing, amine, right? This amine part undergoes oxidation. Hence, it is allowed to form these compounds. So now let us come back and see the next section of your amines chapter. What did we learn in the previous video? You have seen how did I prepare primary amine from your alkane, right? And further, I will also show you the different reactions which are involved with primary amine. We have studied about aminolysis, acylation, benzylation. Yes, we have also seen what is how is it treated with secondary amine, everything, all the list of reactions you have studied. Now that's done with your primary amine. Now let us come to the second class of compound of this particular chapter. So what did I say in this chapter? You have nitro compounds done. You have amino compounds, that is amines. You also have cyano. Then you also have a subclass of compounds, that is BDC, benzene diazonium chloride. We are going to study that. Very important and easiest reaction of this chapter. So here I am going to show you the preparations and chemical properties together. First let us write the full form. BDC stands for benzene diazonium chloride. Okay, what is the formula for this? So benzene, aromatic ring, so I'll write AR. Di means 2, azonium means N2. N linked to one more nitrogen is azo group with N2 because it is di. Chloride, benzene diazonium chloride is this. That. The first important thing, let me start like the earlier one. First I have to prepare BDC, isn't it? What is the procedure? Now you are going to first take, suppose I'm just going to start with benzene. To this benzene, I will try to use a nitrating mixture. Same, it's the simplest basic thing which you have studied. This is going to supply me the electrophile NO2 plus. So this will form nitrobenzene. Simple. Now this nitrobenzene, what am I going to do? I am going to introduce reducing agents. So reducing agents, two types of reducing agents. One can be Sn plus HCl or lithium aluminium hydride. Then these two are reducing agents. They are going to supply hydrogen to this. They are going to add this hydrogen, remove oxygen from here. Then what do I get? I am going to get a compound because hydrogen is added, oxygen is removed. I get from nitrobenzene, I am going to get aniline. Why? This is lost and hydrogen is added. This is called aniline. Now I still have not prepared BDC. From aniline, BDC can be prepared by two methods. One is either if you see in your paper NaNO2 plus HCl, one composition, or HNO2 also the problem. Both will convert aniline to BDC. Both the compound NaNO2 and this one will convert your aniline to your BDC. So what's going to form? Your HCl, isn't it? Now this whole compound is going to get converted to a new compound called N2Cl. From where did I get? Yes, reaction mechanism, I'll show you that also. This nitrogen so forms a bond here and Cl forms a bond here. Okay, so remember that is the reason we are using this in acidic medium also, this and this. So this N2 and Cl, N2Cl. So this, when you see these two, that means they want you to form BDC. So BDC, benzene diazonium chloride. Now to this BDC, just observe carefully. 1, 2, 3 conditions. This is one set to this BDC, 1 and 2. Remember, same BDC, if you are introducing or if you are finding this copper Cu2Cl2 in the presence of HCl, Cu2Br2 in the presence of HBr, CuCN in the presence of KCN. If you see this, observe what happens. First, as soon as you are heating BDC with such things, you're here Cl minus, here Br minus, here Cl, nucleophile. That will replace first when I heat this with these. Nitrogen gas escapes out everywhere. Everywhere nitrogen gas escapes out. So this is going to form a compound called chlorobenzene. This escapes out. Here the nucleophile is bromine. So bromobenzene. Here cyano is a group which is going to attack cyanobenzene. Aparo. This reaction where you are converting BDC to chloro, bromo and cyanobenzene, these reactions are called Sandmeyer's reactions. So Sandmeyer's reactions. Done. Now the same BDC, if I am utilizing or trying to use only copper in the presence of HCl, or if I am using only copper in the presence of reducing agent HBr, if I am getting the same thing, same products like this, Cl, and here the product which I obtain is, this is here Br plus nitrogen gas escapes out, isn't it? Escapes out plus nitrogen gas escapes out. Now, so this particular reaction with Cu by HCl, Cu by HBr is called Gattermann reaction. Gattermann reaction. So remember, important thing, whenever you have to prepare your BDC, try to take this. Why did I do this? Conversions. Convert benzene to BDC. Convert nitrobenzene to BDC. Convert aniline to BDC. So this is your sequence. So see, very simple. The reducing agent, aniline, I am getting BDC, and finally, so let us again meet with next set of reactions. Right, so now let us come back and do the last reaction, which is involving your benzene ring, that is your sulfonation. So we'll also do a question regarding the Friedel-Crafts alkylation and acylation. Let's come back and do this. So whenever you speak about sulfonation of aniline, so what did we learn earlier when you're doing your nitration? I said it is not directly going to, like nitrating mixture will not directly go and attack aniline and form orthopara, but first forms acetanilide, then gradually it's going to form. Here also you have a concept. Let's see that. So in sulfonation, what do you require? What supplies us the electrophile? That is concentrated sulfuric acid. Now, so for sulfonation, as I said, you require concentrated sulfuric acid, which is going to supply SO3H as an electrophile. Sorry. So first you are going to take your aniline. What happens is, whenever you are heating aniline with sulfuric acid, for the sulfonation procedure, is going to take 4 to 5 hours for aniline to form products. So to get your orthopara aniline and the benzene sulfonic acid and para-benzene sulfonic acid, to get products, it's going to take 4 to 5 hours. So let us see the procedure, what actually is happening in the reaction. First, aniline, you are going to treat it with concentrated sulfuric acid. Okay. Now see, sulfuric acid, I can write it as H and H plus plus HSO4 minus. Yes, done. In the step 1, this aniline is going to pick this H plus. And how is it going to join? It's going to just become NH3 plus and your HSO4 minus. Now this is sulfate, isn't it? Now just see how to name this. Aniline, hydrogen sulfate. Done. Now to this hydrogen sulfate, now gradually what's going to happen? You are going to remove water from this. Where are you removing? Observe. 2 hydrogens from here, 1 oxygen from here. Once again, remove water, 2 hydrogens from here, 1 oxygen from here is removed. What do I get then? I get a compound which is like this. NH3 have lost 2 hydrogens, it's going to become NH. SO4 has lost 1 oxygen, so this is going to become SO3H. Now this compound is called sulfamic acid. Remember this, sulfamic acid. Now to this sulfamic acid, now I'm going to heat it to 60 degrees centigrade. Then there's a shift of SOH bond and you get NH2 and SO3H, the ortho position. What do we get? We have got ortho position sulfonic acid. Now let us name ortho amino benzene sulfonic acid. Done. Now this ortho amino benzene sulfonic acid, when you're increasing the temperature to 180 degrees, you get a compound called para-amino benzene sulfonic acid. This is sulfamic acid. This is sulfonic acid. So this is how is your sulfonation done for in case of aniline. In the exam, please don't try to directly write ortho para. Don't do that. You lose mark. Though you know the concept, if you're not presenting it properly, you lose mark. So this is the procedure for sulfonation of aniline.